Hi guys, and welcome back to Physical Sciences for Year 10 of the Australian curriculum. In this video we're going to look at the second section of this course, which is looking at motion and Newton's laws. Now before we start, this video is going to involve just literally getting to grips with the terms of motion, what they are, and what the various concepts are when we put these variables in place. So the first thing we need to understand is when we look at motion, there are two types of variables that we can have. We can have variables which are scalar, and we can have variables which are vectors. Now a scalar variable or scalar quantity is something which literally just says size. So for example, I could turn around and say I'm traveling at 3 meters per second. That's a speed, it's just a size, that's it. There's no more information. Whereas a vector would say I'm traveling at 3 meters per second in an easterly direction. Gives you a lot more information. A vector talks about size and it gives you a direction in the direction, basically stating where the variable is going. So it's really you'll find that vectors are going to be used more and more. Scalar quantities are not going to be used very much. We may use scalar, something like energy would be a classification of scalar because it's just a value, a magnitude, like 322 joules. That's it. It doesn't tell you where it's acting, it doesn't tell you in what direction it's acting. Now, why is direction important? Well, the thing is, when we get on to things like forces and acceleration or what have you, if we took something like this book, for example, if I put a force in this direction, you know that this book is going to go upwards. However, if I placed a force in this direction, it goes sideways. So scientists and physicists basically want to know in what direction is an object going to go. And if we've got more than a number of variables acting on an object at any one time, the net result will push that object in a specific direction. So by being able to work out where the vectors are, where the directions are, it allows us to determine what is likely to happen. Okay, take something like a car accident, for example. If you looked at cars where you've got a pile-up, what you'll find, and what police officers will do, is look at the various forces which are applied and will see how the motion of the car was a direct result of the various forces, and then they can determine whether somebody is responsible for a crash or whether it was an accident, etc., etc., and they can go back in time and sort of see what's happening. So what variables basically come under the scalar and vector quantities? Well, under scalar, what we've got, the variables that we tend to use for motion are distance, the words distance, speed, acceleration can be a scalar quantity, and force. For vectors, we've got displacement, velocity, acceleration and force again. You'll notice that acceleration and force can be used in both areas. Okay. However, distance is changed to displacement and speed is changed to velocity. So whenever you talk about a displacement, you're going to be talking about a size and a direction, whereas whenever you're talking about just speed, we're now just talking about a size, a magnitude. So you need to be aware of that when you look at your questions. If it asks you what is the speed of the object, you don't have to look for any distance. However, if it turns around and says what is the velocity of the object, you need to look at the speed of the object and the direction in which that object is going. Okay, so I hope that sort of pulls into gear what the difference is between scalar and vector quantities. And now what we'll do is we'll look at the definitions of each of those variables. Now speed, as you know, is basically how fast an object can go. Okay, so it's a scalar quantity. As I said, 3 meters per second. The car went at 3 meters per second. It's scalar. It gives me no more information. However, when it comes to velocity, velocity will tell me 3 meters per second in an easterly direction. Hence, it's a vector. Okay, so velocity, you must always look for speed and you must look for the direction. Distance is how far an object goes. We went 3 meters. Okay, that's fine. It's just a value. However, displaced that, we went 3 meters in a westerly direction, we know that we're going to go to the left of us, and basically we're going to go 3 meters. So it gives us a little bit more information, hence it's a vector. Now, acceleration can come under two headings. We can have an acceleration of 10 meters per second, or we can have 10 meters per second straight down. Now, acceleration tells us how much the velocity changes. Now, because we use the word velocity, we're going to be using our speed and our direction. However, we could replace the word velocity with just speed, how the speed changes, and then acceleration becomes scalar, because then speed is only a scalar quantity, there is no direction. So if we had a velocity changing, it means it's either getting faster, it is getting slower, or the speed could be constant, but it's changing direction. So all of those things can be taken into account, and it's a little confusing for some people, especially when we get to acceleration. So for example, one of the classic physics questions is, if you're going around a roundabout at a constant speed, are you accelerating? Well, if you think about it, if we're going at a constant speed, the speed isn't changing. So the bit where it says how the velocity changes doesn't come into account. However, because it says velocity changing, because the car as it goes round the roundabout is changing direction, velocity has direction in there, so the velocity must be changing. As a result, the acceleration must be changing, hence it's going to be a vector. So as you go round a roundabout at a constant speed, you are accelerating because your direction is changing even though your speed isn't. Little bit confusing, and that's probably a high level area of understanding. We really deal with that in a lot more detail in our Year 11 physics course. And finally, we've got force. Now, force is the work that has to be done on an object to promote a movement, and this comes under one of Newton's laws. Newton's second law, F equals ma, basically means that a force must be applied on a mass to cause an acceleration, to cause a change in speed or a change in velocity. So hence, force can be a vector. However, force can also be a scalar quantity if we just use a value. So if it had a force of 10 newtons, okay, it had a force of 10 newtons, it doesn't give me any direction, so I don't know how it's going to be affecting a specific object. Could that force of 10 newtons be pulling an object up, or could that force of 10 newtons be pulling the object down, to the left, to the right, forward or back? I've got no idea. So you can see that a scalar quantity is not particularly useful, whereas a vector quantity is going to give us a lot more information, and from that we'll be able to work out how the motion of the object is going to change. It is really, really important that you understand these definitions and learn them early on, so that as we go through the subsequent lessons, you'll be able to understand and apply those definitions correctly. Okay, well that explains most of the all of the terms of motion that we're going to be using in this unit. Hope you found that useful. Do go away and read through these definitions so you've got them clear in your head, and then we'll start utilizing them in the next video. Thanks for watching.